Well, good evening, everyone. Um, was I audible to you? Can someone please raise your hand and respond with the emoji? Okay, fine. Thank you. Okay, I'm going to start the class now. Okay, as of we all here, just because of Internet of Things, IoT, and let's check what was the contents I'm going to cover. The evaluation of Internet, IoT in the general world, IoT for technology for professions, technical, how need of an IoT embedded systems. And today I'm gonna go with the content of an IoT for the general world. As before I have explained, let me revise for some time this yesterday's session. Okay, basically the IoT was a network of an interrelated devices that connect and exchange the data within IoT devices and the cloud. Majorly it stores on the cloud, and these devices were typically embedded with a technical such as the sensors and the software, and it gonna be included some of a mechanical and the digital machines and a consumer objects. So the IoT has been major part in just because of an industries and some often organizations they have been using this thing called IoT just because some more specifications to often operations, which was a more efficiency and the deliver enhance the customer services, and the major thing was decision making and the value of a businesses. And the main advantage of an IoT was it doesn't need a human to human interaction, just like smart applications we can be applicable it will be. And the human to computer interaction doesn't it require if we use some sensor or some software terms to that hardware, and it can be operate itself with the smart way of an application. It doesn't require any humans to enhance the work. So, as mainly it doesn't require any human to human interaction, or else it doesn't require any human to computer interactions. So, it is like example, it has been inbuilt within an automobile, has been inbuilt within sensors to alert the driver when the tire pressure is low. Okay, when the tire pressure was low, the driver have gotten with some kind of an alert just because of the sensors which is being inbuilt. Okay, it saves the person in the same way. It saves in not only in this one term, in this different gadgets and different terms of applications. It's going to save so many lives. And it is the man-made object can be assigned on an internet protocol that addresses and it able to transfer the data over a network. Okay, by adding of an internet protocol address, it can transfer the data over a network actually. Okay, so in this way it's going to help in our daily lives, and not only in the small applications of like home and offices, but also it's going to be help on a biggest platforms, just like a gated community and big countries and etc things. It's not just being of a small thing, it's all of major parts and the minor parts too. So why it was important, basically it helps the lives of human beings, and also not only human beings whatever, and it works smarter as compared to so many other networks. This network basically it helps in so many ways, and also it makes a time saving, the big time saving thing. Just like an example, smart cars and smart watches, etc. These all things will improve our life, and it saves the time and it works smarter as compared to the other networks. And it's the most important technology actually, and it continues in advance as we know. And in advance, we're gonna get more of implementations. And in not only in the technologies, but also in the business categories, it has a high potential, and it has being so competitive in the business sectors. And the IoT was mainly used at artificial intelligence and machine learning to add the making of a data collection as a process just of easier and a more dynamic in a way. Okay, it has been used a lot in artificial intelligence and machine learning to for our making of a data collection actually. and to make easier and a more dynamic of an work, as we know. And yeah, this is it's a network basically. Whatever wherever we go, it's a type of a network. It just does the thing. And yeah, coming to the evaluation of an internet, just like yesterday's topic, and just I'll revise the whatever thing I have explained is tomorrow, just like yesterday. Now I'm going to explain what is what. And then the evolution in internet has been the thing. The whole scenario has been started in the year of 1830s and 1840s, which was a thing called like nowadays we are saying like the thing called internet, but not the thing it was before itself. And there, in the earlier days, is we only say that it's a communication. It's just often a communication. From the communication and the step-by-step process, it has been implemented like an internet of a things, and it just became a whole universe with this internet of a things, of implementing of a new things and just being a smart ways. Okay, the first thing it has brought up like a communication thing with a telegraph, which was the first landline, and it has been developed in the 1830s and 1840s. Has been described as a wireless telegraphy, and yeah, it was the first wireless telegraphy, and just like with first radio voice transmission, which took place on a 1990 at the June 3, providing a necessary component for developing of an Internet of Things. And it has been begun in the 1950s itself, the thing called internet. And then on later, the Kevin Ashton, the man who just bought this thing called Internet of Things in 1999, and he described the IoT, and he took a making a present while the making of a presentation of a Procter and Gamble, which was a good services, which is a type of an services. Well, after that, it becoming a broader and faster terms in connectivity, and then it has been refers as a millions of physical devices that are connected to the internet and provides a platform for every industry to a faster innovation and productivity. Just like this. Actually, IoT is an ecosystem which is connected as devices and exchange data, just like I have said before. And these devices would be included just like a smartphones, laptops, smart electric applications, smart office equipment, or an etc., which tagged with an sensors basically. The sensors and the software or else and some mechanical which is included of digital machines and consumer objects, etc. things. It has been inbuilt with a tagged sensors. It has been it's nothing but a transmission of a data which habit it, and it helps the gadget to help in such a way to us. Most of the 90% of this IoT will be help us for our daily works and security alerts. So many of things. And then later, the data has been generated by the devices shared within a located cloud. Just like I have mentioned before, it is all about exchanging and connecting of a data devices, whether it's a cloud or on-premise and etc. The on-premise Premji was defined as it is a base of a work, means the place of a work where it is proceeded to gain insights and help of taking decisions. Just like I have said, in the industries, this point gonna be so much of it's raised. It's like improving of an decision making in the industries. If we observe, the development was the most important as compared to the other sectors, because as we inbuilt the decision makings of advanced, then the marketing gonna be so healthy and a faster and a profitable, which every marketing required in these days. So in that way, this IoT gonna be help and a major advantage with them. So yeah, in that way, the IoT app ecosystem has been established not only within a small areas. Yeah, just to have mentioned this before itself. It is not for a home or an office sectors, but also it has a major advantage of a gated communities and cities and etc. It has been used in overall the countries and etc. etc. Not only in the place of hometowns and etc. And yeah, it is all about smart devices that connect within each other with habituous part of our life, with habituous defined as in presence. And it's a part of our life. Yeah, just like I have mentioned, everything, the home applications is nothing but a part of our life. We use everywhere the home applications. So yeah, we use in the home applications as well as in offices, in the cities, in the malls, and etc. We use the IoT. It's like they have mentioned that it is a daily day life of a part of our lives. And in the individual user business, providing IoT products and services, yeah, and everywhere in the products, just like I have mentioned this before, in the business and the goods services and etc. We the IoT was being a high range of a profit, and we are using a lot and lot and lot. And yeah, it makes sense of understanding of an evaluation of an IoT knowledge. Yeah, just like I said, it makes sense because everywhere we are using this IoT in a daily way applications or in a some other kind of a ways we are using this valuation of an IoT. So the people were habituated and just made sense that it was a daily day life. The daily day life required IoT. Without IoT, they're gonna not lead that easy life. Yeah, yeah. Yeah, the force in the future, and you may use this technology in advance, not in yeah, like just like at the present, how inbuilt it is a great way. In the future itself, we can see more of a changes by implementing of a new network and a new devices and a new gadgets and etc. etc. We can see so many changes and the life saving things in the future itself. And yeah, just like coming to the milestone, in 1989, the man where bought the World Wide Web, the foundation of an internet. He bought the thing of an internet to the platform, just like World Wide Web with the name. You know the World Wide, like you couldn't connect me right now without the internet and the things, right? So yeah, in the 1989, the Tim Berners he proposed the framework of a World Wide Web, and yeah, you know how really it has been went on through. And in the 1990, the John Romkey developed the toaster. No, yeah, opening server is a fine, but how to close a server, right? So the John Romkey has been bought up the thing, how to implement the start and the stop of the thing. And then yeah, the yeah, in ancient days there was there was only a wide internet. There was no wireless internet. So on the flow itself, he had got up know that there was no Wi-Fi then, and then he considered that the first thing is that began to Internet of Things. So as soon as the researchers and the scientists has been thing for a coffee, like coffee or hot or not, they got to just had an idea that whether coffee is hot or not. Just it is a story of a back one, Kelvin. Yeah. In the 1993, the Rosen Room Coffee has been built at the Library University Cambridge, acquired in a qua staffed register and a Paul Jatke in 1993. Yeah. As this says about after seeing that they have confirmed there was an image was viewing in online. Yeah, there's something the data has been viewing in online, which was an image, well, like what they have experimented in that way. And next, the other milestone was came on in 1999, which was just the man who bought the basic line of IoT, the Kevin. Even he coined the Internet of Things, the term. He coined the Internet of Things, the term. And then so on, the term IoT. The term IoT has been used as a mainstream of a mainstream publications in the Scientists of American in 2003 and 2004. 2003 and 2000 in the between of a four. The RFID has deployed as a US Department of Defense and a Walmart in the stores because they have bought the thing called not only for the device, but they just bought up for and they have just been bought up for and stores, and they made a appearance of an IoT. They have made an appearance of an IoT. And then later the US has been just implemented that thing, and then later United Nations International Communications, United Nations of an Internet Communications has union acknowledged that the impact of an IoT in a report of 2005. It has been predicted that the help of creating entirely new dynamic network of networks. And then later in March 2008, the first IoT conference has been held in a George, where it brought together our researchers that that the both academic and industry facilities sharing the knowledge. So then later they come to know that it's not the thing of storing in some kind of market, but also it can be used for the researchers and the practitioners that like in the academic way and industries way also. And then later they have shared some kind of a knowledge. In the same year, the US National Intelligence Council has included that the Internet of Things has to be as one of the six respective civil technologies, and they have made this thing a little larger by having a civil technologies. And in the earlier age, 2011, this main part, which called as a white paper, Cisco Internet Business Solutions Group had bought truly it to be a bond in between the 2008 and 2009, which was a number of things they have implemented the thing called the person has to be connected through a network. Like they have checked how many members going to be connected to the network, and with the survey they come to know that the ratio was approximately 0. 0.8 in the 2003 to the 1.84 in the 2010. So this thing called white paper, which they had brought up in the 2011, the CIBSG has said that it is truly has been born in between the year of 2008 and 2009, when the where the number of things has been connected in the internet and exited and the number of people has to be connected to it. So by the calculating of this ratio, they come to know that 0. 0.8 in the 2003 and the 1.84 in 2010. And then later after completion of this survey, they the together with a white paper and a Cisco released with many of an education media. See, before we have seen that it has been implemented for academic and the marketing sector, but now it has been implemented through one more big platform. It's like a marketing clients has to be adopt. They have adopted the IoT, and the after some time, so many races followed up. In the year 2011, the granted included that the IoT in a hype cycle for emergence in the technologies that were on the rise. And then so on. They have report in 2030, the IDC were released reported that IoT market has been grown of a 7.9 percentage and the reached to USD of an 8.9 trillion by the 2020. As we see how much difference it has been increased in the with the past few years in between. So yeah, whatever the white paper from the white paper. The Cisco has been decided that the thing called then the marketing sector and the everything sector has been majorly developed, and it just became a trillions in coming the year of 2020. So in that way, it has been inbuilt, and let's see the flowchart of that. In the 1982, the Coke vending machine, the idea of a Coke vending machine and the doubt and the quarry of the Coke vending machine has been started. While that continuing a process, and then World Wide Web has been bought up by the Berners-Lee in the year 1989, and going on and John Romkey has been toasted that connected to the internet, and and also he brought up how to end and start the server, and then later the coffee story, coffee story has been happened whether it's a hot or cool. So and then go on the man who brought up the Kevin string, he termed the IoT coin, which was there was a Internet of Things. Actually, we need to go through it. He bought in that such an idea, and then in 2005, the International Telecommunication has reported that the thing has they have reported the thing IoT, and then later 2008 the first IoT conference has been held it, and then 2011 they have confirmed that there was a huge high cycle in the IoT all over through technologies. And then 2013, they had reported there was a 7.9 percentage has been increased in the 7.9 percentage has been grown. And then later in with the reach of a USD 9.9 trillion people has been connected through the internet in 2020, which is a huge scale compared to the previous 2013 and 2020. Yeah, this was the timeline evaluation of an Internet of Things. This we have where we have discussed this yesterday. This is a revision. And then coming to the other topic, which was an IoT in a general world. Yeah, let's see. Uh, IoT in a general world, just like I have said so many examples just before, you have seen, right? Yeah. It is a most abundant manufacturing, transportation, and utility organizations that, yeah, it's like a sensors and the softwares, and they include some digital missions and the consumer things. They use this IoT in such cases of an within they use this IoT in so many ways in a daily life. And coming to the agriculture, the first weather they have mentioned. Yeah, the agriculture in real time. The IoT of a smart agriculture has been this product has been designed to help the monitor of a crop fields. Okay, to help the monitor of crop fields by using the sensors and by automating the irrigation systems. Okay, the two major things was to monitor the crop fields by using a sensors and automatic irrigation system. Okay, as a result, the farmer and associated brands can be easily monitor the fields of the conditions and whether in any way without any hassle. Okay, without any hassle, they can easily monitor and associated with the brands for resulting of a good sensors and irrigation processing. So the basically the IoT smart agriculture products has been designed to monitor sorry, to help the monitor crop fielding and by using the sensors and automating of an irrigation systems. Okay, in that way, some that took place in different uses actually. Uh, let me explain some uses. The robotics in agriculture, for example, if we take since the industrial evolution has been started in 1880s only, they got more advanced and efficiently to handle the sophisticated tasks, and they increased their production. Okay, in 1880s they have started this evaluation, and then they got a more advanced as we saw the history just before itself. I think as we saw the history just before itself. Wait a minute. Okay. The robotics in agriculture, wherein this evolution has been started in 1880s only, and then they got for more advancedly handled by the some kind of a task, and they have increased the production even with an increasing of a demand and the shortage of labor across the global and by the thing called agriculture robotics, or commonly known as in a agripods, which was started to gain attention among the farmers. Okay, this production has been started to gain attention among the farmers, and it has went through the globally for agriculture, because the agriculture doesn't have a more of equipment as compared to the other sectors. So they have bought to the agriculture basically for the first thing, and in the crop production they have decreased by an estimated of 213 crores approx, and a year due to a labor shortages. The USA, in the first in the USA, it has been implemented, and advertisement, and they have held some advertisement sensors, and AI technology has been let the emissions are strained in their surroundings, that has made robots more notable. And where you're still in a real ages of an AG robotics evaluation and full of a potential of an Internet of Things in agriculture, which is that most of the products are still in alien in trial phases and are R&D mode. The alien is this IoT was in still they are using the thing, but the more or not in every country they have been not using this, and they were in a trial terms morely. Okay, the research development and a diffusion model, which was R&D is defined as, and it is a linear and systematic model actually. And the steps were research, development, and diffusion. This was the steps of step of an R&D model. And yeah, they had estimation in the USA. It has been implemented the firstly, and then they tried to gain attention towards the farmers, and the production has been decreased and estimated of to 13 crores approximately in a year of a labor shortages in the USA alone. And then for they have made some advanced sensors and advertisements, and they have brought up the AI technology to the machines to train the surroundings to make the work of a success. And then later they have started the thing called vending machines, vending robots. The smart agriculture robots are digital image processing to look through the images of a weeds of their database to detect the similarities with the crops, and a weed to spray on them directly with a robotic arms. Okay, with the robotic arms, they got the robotic arms gonna spray the weed with like it pass some material in between them, and they detect the data even for that crops. And with an increasing of a number of plants, they have become a resistant of a pesticides, and they are born to the environment. And also the farmers has been used spreaded the pesticides to throughout the farm. And as an estimation, the 13,000 of kilograms has been they had repeated the applied the as a cost of the 1.725 crores each year. They reduced their overall cost even. Okay. They has been used the robo arms for spreading of some seeds and etc. facilities to the crops, and with the images of a scanning agriculture robot digital image scanning, they used to scan the weeds database and they used to detect the similarities. The work of this was this, and then later they brought up with a mission navigation. Okay, as the remote controlled toy cars are enabled with the controller, right? So in that way, tracks and tractors and the heavy pulling equipment has been run automatically from the comfort of a home through the GPS. Okay, the remote controlled by the toy cars, how we have enabled. In the same way, the tractors and the heavy pulling equipment have been automatically from the comfort to the home to the GPS. It has been passed. They integrated the automatic missions are highly accurate and self-adjust when they detect the differences. Okay, the trainers, and simply the labor intensive task was they have planned some automatically passing of an passing of an tractors and a heavy power equipment with the help of a GPS. They have made a system to train like that in that way, and in this way, the self adjust that has been started for the tractors and the vehicles. And then later, they detected some differences in the trainers, and they have simplified some things, and their movement as well as the work in progress has become easily, and they can check the data how like we can normally if we passing some distances by following the GPS, we check the smartphone, the same way. And even that same application has been implemented for these also, is to check the smartphones. They have this thing called has implemented very goodly way uh machine navigation, and with some advertisements in the IoT agriculture and the machine learning. This tech has been driven very well, and then later they have went through the harvesting robotics. Harvesting robotics was like it is like utilizing agriculture robots to pick the crops to solving the problem of labor shortages, and the working of a delight process of a picking the fruits and the vegetables to innovative machines can operate the 24/7. Okay, the harvesting robotics. The harvesting robotics can be invented with the 24 hours of a working sector, and the working of this was in a picking of a fruits and the vegetables in a innovative missions. Wait a minute. In the same way, it has been it can the work can be done by the 24 hours, the major advantage thing, because the humans couldn't work the 24 hours, right? So it can be work on 24 hours by combination of image processing and a robotic arms. Okay, as we have seen before, only the two processors having different operations. But coming to here, it can be image processing and it can be form a robotic arms by using of some machines. And these they will be pick the fruit by controlling the quality. And due to it has a very high operational costs, and the crops has been really focused on this sector only. And then just like crops like mostly has been using this by the for apples, the greenhouse harvesting has also found the applications. With this boards of high value crops like tomatoes and strawberries, this board has been worked in a greenhouses to apply a determine and the stages of a crops and harvest them in the right time. Okay, the high costed values crops has took this thing called harvesting robotics, and they have implemented for their purposes because it was the two operations at the same time, which was an image processing and the robotic arms for their missions. Okay, and the major advantage of a harvesting robotics was it can work on a 24/7. The working was picking of enough fruits and vegetables and providing the nutritions with the robotic arms and image processing, how the processing has been done for like the growth of a plant and the fruits and etc. things. It processes the images and it says the details by encoding. And in the same way, it uses work by 24 hours. And majorly the high crops like apples and tomatoes, strawberries, these highly costed valued crops will be using this system, which was a harvesting robotics, which was harvesting robotics. And and then the other thing has been that took place, which was a material handling. Okay, the material handling. It even it was a format of a robot. In this, the robots can perform the routine manual labor task working alongside with the labors. Okay, it can make the task by working alongside of a labors. Okay, they can lift the heavy materials and they can perform the task like a plant spacing with a high accuracy. Okay, therefore the optimizing often has space and the plant quality and the reducing production will be costs. So the working of this was it can act like just like a human. Okay, it will do the work just like a human by of working of a task by along sides with the labors. It do the main working was to lift the heavy materials and it performs a task of a plant spacing with a high accuracy, and it also optimizes the space and the plant quality and it reduces the cost production. Okay. Yeah, this was the robotic usages, which was okay. In 1880s, there has been started the processing. In the robotic agriculture, they really perform the weeding robots, which was image processing, and machine navigation, which can pick the which sorry machine navigation, which can make the tractors or vehicles to be go on a way of a comfort of a home through the GPS, and we can check the data in the smartphone, just like our natural way of processing vehicle. And then the harvesting robotics, I have said that it's a combination of image processing and the robotic arms, which we can use in the machines, often to determine the pick the fruits and controlling the quality. And it's gonna be processing on 24/7, where compared to the other sectors. So it was the most advantage thing. And last but not least, the material handling. It can be in perform of a direct manual labor while working often along just like a labor. It just work like a labor by lifting often heavy materials and by performing the task of a plant spacing with a high accuracy in this way. It just does the work. And next one was coming to the drones in agriculture. Like I was repeating, drones in agriculture. This has been used to enhance and optimize the various farming activities, just like a crop monitoring, spraying, soil analysis, and the mapping. Okay, I was repeating again. The activities it performs is like a crop monitoring, crop spraying, soil analysis, and the mapping. Okay, this was the activities it performs, and it will be enhanced and optimized in using these activities. In fact, agriculture is one of the major sectors, as we see, to incorporate the drones. Okay, the drones are equipment with the sensors and the cameras by using a imaging, mapping, surveying the farms. Okay, three sectors it's going to be more helpful, which was imaging, mapping, and surveying the farms. Okay, this is the ground-based drones actually. As we see normally, the drones has been operated for a high ranges, but coming to here, as we know, the agriculture is all of down to earth. So yeah, down of the landing. So these drones specifically used for a ground-based drones and aerial drones also. And the ground drones are about to that the survey the fields further on a wheels. Okay, the survey has been implemented as a field on a wheels, and aerial drones has been famously known as an unmanned aerial vehicles, okay, or as an unmanned aircraft systems. Okay, these were a flying robots actually, and these drones has been controlled or remotely or also fly automatically through software controlled flight planes in their embedded system, and the working in going to be coordination only with the working has been done majorly for the drone was with a combination of a sensor and the GPS. Okay, the working of a drone going to be done with the majorly with the two sectors, which was on sensors and the GPS. Okay, from the drone data, the insights can be drawn regarding to the crop health and irrigation, and spraying, planting, soil, and the field plant counting, oil production, and the much more. These are all things one be insight in for the from the drone data. Okay, it's going to recognize the crop health, irrigation, spraying methods, sorry, the spraying qualities, planting, the soil quality and the growth, field, the whole field, and the plant counting, L prediction, and much more. It's going to be recognized and going to perform the task that analyzing these things. And the drone going to be LLA has been scheduled as a farm services. Okay, I mean, it can be bought and stored in any of the farms where we can be recharged and maintained. Okay, these farms can be recharged and maintained. After some services, the drones has been taken by the labs to recognize or the data has been collected or they've been helping of an leverage of an IoT agriculture data. And yeah, in this way, it's gonna be really operate, which was a drone in agriculture. Usually, it operates in the two ways, which was on a ground-based drones and aerial drones. For the ground, the whole scenario of a drone has been morely concentrated on the things called health, crop health, irrigation, spraying, planting, soil health, and a field maintenance, and a plant counting, L prediction, and a much more. And this, yeah, they'll it checks the weather, all the qualities and etc. The things, and it would be collect the data It would collect the data and it's gonna be stored, and it in rather latter days they're gonna check whether the formation of a whole scenario was done with exact data or not. And then later coming to the next thing was remote sensing agriculture. Okay. The term remote sensing agriculture was being revaluing the way data is acquired from the different nodes of a farm. Okay. The IoT was based on the remote sensing utilizes. It is all about sensors which was placed among the farms like a weather stations. Okay, for gathering a data. Okay, this thing was placed with the farms like a weather stations for gathering a data. Okay, which is transmitted to analyze the tools for analysis. The sensors are devices sensitive to anomalies. The farmers can monitor the crops from the inelastic dashboard and can take action based on the insights. Okay, in this we can take an action. The main thing was okay. In this we can take the action, and it would be in between the farms only. The work of this was to weather stations of gathering a data. Okay, the work of this was a weather station to gathering a data, and it transmits the analytic tools for analysis. Okay, this was the work of this. In this, there was some other sectors, which was a crop monitoring. The sensors in this crop monitoring, the sensors been placed in among the farms only in the monitor. That crops can be changed light, humidity, temperature, shape, and as you know, these things which was a light, humidity, temperature, shape, and size is going to be they detect by the sensors, and they are going to be analyzed, and the farmer going to be notified these things. And then the remote sensing can help the prevent and spread the diseases and keep an eye for a growth of crops. You know, these major things, the temperature, if the temperature was high, the crop gonna damage. If the humidity was high, the crop gonna damage. If the shape was unfortunately happening, then something, some kind of disease gonna be arrived to the plant, right? When the size was unfortunately has been happened, then we have to check the whether the soil has some bacteria, also we have to check in that way, no? So in that way, if these terms, which was a light, humidity, temperature, shape, and size, if this was not in a format of exactly, then something gonna be happen to the crops and they're gonna be spoiled. So this was the main thing of growing in the stage of a growing. So this crop monitoring, the remote sensing in agriculture, measuring this crop monitoring concentrates on a light, humidity, temperature, shape, size. They analyze the data and they store, and by that analyzing of an sensors, then the farmer can be notified whether the problem is what and whether they're spreading a diseases or some kind of he cannot check and analyze every day. So it's like keeping an eye on a growth of a crops. Okay, simply I can say that it is of a keeping an eye on a growth of a crops. And then like latter, it also concentrate on the remote sensing, also concentrate on the weather conditions. Okay, in this weather conditions, the data can be collected by the sensors in the terms of just like moisture prediction, new detection, temperature, humidity. They determine the weather pattern in a farm so that the cultivation is done with the suitable crops. Okay, the pattern of a weather it gonna decide. Okay, the pattern of a weather gonna decide, and it's gonna be done by the suitable crops. Okay, okay. Then coming to the remote sensing of a soil quality. You know how important for the crop the soil quality was. Yeah, the soil health analyzes the help of determining the nutrient value and the drier areas of the farms. Okay, and the soil drainage capacity or also an acidity, which allows for adjustment of amount of a water needed for the irrigation or upting of a most beneficial type of a cultivation. The soil health can be also help in the leverage of an regenerative agriculture by providing an insight into the how and when it was increased in organic matter. Thereby, the achievement of a better soil structure and eventually have a path of a climate smart agriculture. Okay, let me repeat again. Soil health analyzes the helps in the mostly for determining the nutrition of a value and the drier areas of a farms, and also mainly soil drainage of a capacity or an acidity. Okay, it analyzes on a mostly on the nutrition of a value, drier areas of farms, and the soil drainage of a capacity. It allows the adjustment of amount of water it needed and irrigation and the etc. beneficial types they have needed. It checks whether how much it's really needed and adjustments have for the crops, the like the processing of the crops. If any insights were being happen. So yeah, the soil health data has help in the leverage of regenerating agriculture. Yeah, some just like this only. They increase the organic matter and therefore they can achieve the better soil structure or eventually they can have a path. So in this way, it checks the majorly the soil quality or the remote sensing of a soil quality checks the whether the nutrition value is good or not, or a drier areas, or a soil or drainage capacity, etc. Acidity mainly. They check these terms and they'll analyze after getting off any data from it. So in this way, the remote sensing can be monitored with the three sectors, which is the crop monitoring, weather conditions, and soil quality. And next, the computer imaging in a agriculture. You know how important it was. Uh, Computer imaging in agriculture. The computer imaging agriculture involved in the use of a sensor cameras, which was installed in different corners. Two of the farm or a drones equipped with the cameras. It produces the images that can undergo with the digital image processing also. That image processing is in the basic concept of a providing, processing the input image using the computer algorithms. With the just simply I'm gonna say this because like it is all often a capturing of an image, digital image processing. Okay, it captures and it is a basic concept like a processing the input of an image by using a computer algorithms with this kind of algorithms we're gonna process this and we go when we can get the output of a digital image processing and in a different and that image processing can be done with the different corners in the different areas. It just depends upon the member who gonna choose this angle. And this compares the images obtained over a period of a time. Like in different periods, they capture the different images and they'll compare whether it's a healthy or it is monitoring a great growth or not. They analyze the limiting of an factors and they help in the better management of a farms. In this way, it's gonna help. And uh, the smart agriculture was on we can say it's going to be simple words. It includes every object that can be controlled through internet. Okay, in the crops, in India, it is only the man-made thing going to be only man in the presence of a man. Only so many things going to be observed. But coming to after coming of an IoT, so many things can be controlled through an internet only with the different formats. Okay, this device has been complete in a consumer markets with a variable of a internet of variable things such as smart watches and home management products like Google Home and this way. And it has been estimated over 30 billion devices could be connected to the internet things by the 2020. They come to know that. And the applications of an internet of IoT agriculture mainly targets on the convention of farming operations to meet and increase the demand. Okay, it mainly concentrates on a increasing of a demand and decrease the production losses. So it's gonna help the agriculture not to make any loss to advantage the each and every sector when it comes to the soil or an observation or coming to any bad nutrition occurrence in that way. By using drones, robots, remote sensors, and the computer imaging combined with the continuously processing and with some machine learning and analytic tools for monitoring crops, they in the survey. Like basically, they record everything data what has been held in between with these robot sensors. They're gonna survey the things whether the previous day how the data and this day how the data. It is all about surveying and the mapping the fields also. And this provide the data for farmers in a rational form of managing the plans to save both time and money. If we observe the most of the thing in this IoT agriculture of a smart ways has been major points was and major advantage was the time both saving time and money. Okay, the both sectors the time and money was the most important in every sectors. But coming to here farming, we have to be analyzed 24 hours because we don't know whether how it gonna be changed. The weather, we don't know how the weather gonna change. We don't know how this is gonna occur with through which air we gonna don't know occur. So it required it required a major observation. So in this way, the smart agriculture system often using IoT in simple ways, we can say that while using with the using often robots, drones, remote sensors, and the computer imaging, etc. This thing's gonna really make a huge usage of crops for identifying a data and collecting a data and recognizing a data and by surveying the whole scenario till the crop processing moving on is going to be helped in this way. And yeah, the role of agriculture of an IoT was just like a precision of an agriculture that uses some kind of just like drone sensors and like computer imaging integrates and it monitors the crops and the placement of a physical equipment in the plots of it monitors and records the data and it's going to be get usable of valuable insights. And the major points of these word sensors, the sensors gonna make a big change as compared to the other networking. And it required the high skilled field staff to be, it doesn't, we can monitor with our smartphones even. And the equipment was not a bit expensive. It reduces the maintenance of a cost of an hardware and it has a heavy initial investments and there is no supply chain management and no log of information and it's difficult to integrate with an already implemented devices. But yeah, it's off on IoT agriculture. And then later sensors and the drones are gonna play a major role like by capturing some data through the different various and the different terms it's gonna make sense more of it because surveying was the most important in a agriculture field. We don't know how it really gonna be implement gonna be went the next day the change is gonna be happening the next day we gonna be destroyed even in the earlier stages in an earlier stages. So in that way, the agriculture gonna be use the IoT. So in that way, the farmer's gonna be beneficial by making of a job easier. Okay, let's discuss infrastructure and home automation. Like, okay, let's see how the industries of an IoT gonna be happen. The industry of an IoT was it was all about using of a smart sensors, actuators, and other devices such as an radio frequency identification tags and to enhance the manufacturing and end industry processes. These devices are networked together to provide a data collection and exchange and analysis. The three terms we have to be get noted, which was it collects the data and it exchanges the data, it analyzes the data. The work of an IoT in industries was. In such, they gain the forming of processing the more efficiency and reliability. As we know, the industry internet it is used for the many industries and including the manufacturing and energy management, utilizations, oils and the gas, etc. So it is all about using of a smart sensors, actuators, and other devices. Okay, it is all about smart sensors and actuators and other devices just like a radio frequency identification tags, just like example. In that way, it enhance the manufacturing and the industrial processes. These devices between work together to provide a data collection, exchange, and analysis. Okay, it's all about the data collection of an exchange and analyze the devices when the industry in different formats. So it gains the form of a process in that way. This use a power of smart machines and the real-time analysis to take an advantage of a data that dumb the machines have been produced the industrial settings of years. The driving of philosophy behind the IoT is a smart machines that aren't any better than the humans can be at capturing and analyzing in the data real time. So the humans could have been operated in the real time, but yeah. Uh, but are they also communicating important information that would be useful for drive business decisions faster and more accuracy compared to other. So the connected sensors and actuators would be enable the companies to pick up the inefficient and the problems of a sooner by saving the time and the money. They can support the business intelligence efforts and in manufacturing specifically. And then IoT of a potential will provide a quality of a control, sustainable and a green practices, supply chain traceability, and overall the supply chain has been efficiency. In an industrial setting, the IoT key processes such as an predictive maintenance, enhances field services, energy, and management and assistant tracking. And let's see how it's going to work. It is a network of intelligent devices that are connected in a forms of monitoring, collecting, exchanging, analyzing, just like I have said before. In each industrial IoT system, it consisting of the following things. It consisting of following things, which was the connecting of an devices that can make sense of communicating and the storage of information themselves. And also, other major thing was to uh, is to public and a private whatever the data communication has been inbuilt with the just like an infrastructure. Okay, the data communication will be private or a public. It's gonna be inbuilt with in some kind of an infrastructure. And the next thing was analysis and application that's going to be generate with the business information from a raw data. Okay, from a raw data, the business information going to be generated by analyzing and applications. Okay, and the next major thing was the storage of a data, which was generated by the IoT devices only. Now, how important the storage of a data in every sector, in everywhere. So that going to be lead by the IoT only. Okay. The first thing was the connecting of a sense. Whatever the devices you're gonna connect, it's gonna make some sense of a communicating and the storing information about themselves. Okay. If whether the device having a data, it has to be communicate and it has to be make sense and it has to be also stored by themselves. Even coming to the private or public, it just have some communication of infrastructure and it analyzes and it generate raw data in between the applications of a businesses. And then, as we know, the storage data that has been generated with the IoT only. And these edge devices on intelligence transfers the information directly to the data of the communications. Okay, it transfers the data with the communication. When it's converted into the actionable information, and a certain piece of a machinery is going to be operated. Information could be the predictive maintenance as well as optimizing often a business processes. Okay. First thing, it process the data, it analyze the data, and the application integration and everything will perform, and then go on. In industries, it's gonna be some numerically the data gonna be using IoT was some there are some examples. Yeah, I think. It connects the machines, industries of a manufacturing, transportation, oil, etc. things we have discussed. Basically, the role of an IoT would be at the level of a network, which and the organizations and relay the more and more quality and quantity of a data from their operations must be served and ensure that reliable network within it having sufficient bandwidth capacity in its place to time, sensitive data and come out with being transmitted with a delay to the applications in a data centers on the or of a cloud. These networks basically connect the IoT devices and the sensors needs to be support a diverse physical channels. Just an example, the internet cables connect the devices which commonly found in a factory floor, right? So in that same way, the wireless technologies such like a 5G, 4G, and NFI, RFID, Bluetooth, etc., would be also maybe done with the required of some base of a network of a connectivity. So in the same way, the network of an IoT would be must be highly available actually. And it's gonna be a numerically spread across a large geographical area. But the network controller could be automatically networking with equipment of a deployment and keep the configurations to be constant. And frame work would be always getting updated. It will also help by the ensuring of devices of a performing expectations and the guide administrations. It take corrective actions if not. Network controllers that have been survived the past cloud serve IoT just like as equal. The security and critical resources for the IoT world and IoT world mean it has a security of practices must be coverage and and protecting the best done for comprehensive aggregated security solution but rather than the multiplicate of a point of a products. In the same proven the security that the tools have been deployed on over the years can be beneficial IoT as well as. Let's see some applications of an IoT in the industrial sectors. Okay, the automatic industry. Okay, the automatic industry uses the robots and it helps proactively maintain some systems and spot often a potential problems that gotta be happen before the repeat of a production. Okay, automatically it was a processing of an automative which industries can also use the devices to collect the data and from the consumer systems and it sends to the company systems. Okay, the data is used to identify the potential maintenance issues. Okay, and coming to the agriculture industry, uh, it senses the collect the data about the soil, just like we discussed about the agriculture before itself. In the soil, with the soil of a soil nutrition, moisture, and other variables, soil nutrition, soil moisture, and other variables of enabling of a farmers to produce the optimal crop. Okay, the oil and the gas fire industry. The same oil companies and the maintain some field of autonomous aircraft that use a visual and thermal animation to detect the potential problems in a pipelines. Okay, they have a major thing which imaging of a detect the potential problems in a pipelines. This information could be combined with the data from the other type of sensors to ensure the safe operations. Okay, and this is the work of this is the work of an oil and the gas industry. It detect the image processing of a potential problems in a pipeline. Okay, utilities were being it is used for the utilities coming to the utilities of industry IoT. It would be used for electric, water, gas metering, as well as the remote monitoring of any industrial qualities, which equipment such as transforms which has an equipment of a transform. It was basically used for an electric or a water and a gas metering, as well as a remote, as well as remote monitoring. But the benefits of IoT was when it has a predictive maintenance. The organizers can be used as like just like as a real-time data generating from an IoT systems. It predicts when the machine needs the service. And in the same way, the necessary of a maintenance can be performed for before the failure occurs. You know, it alerts the organization to before occurring of a fail. It just show the some data when it was coming of a danger, the main operation was, and it's going to be especially the beneficial on the production line actually. When the failure of a machine made a result, work stoppable, and it has a huge cost. But the productivity addressing of a maintenance issues, like just like I have mentioned before, it's the if the occurring of an issue of a maintenance, if we address before itself, then it's gonna be have a low chances of failuring the productivity as an it can ensure the better operation efficiency, and it has a more efficient field services because the technology helped the field services technologies to identify the potential issues in a customer equipment before the major issue. So the enabling of a technologies this fix enabling of technologies that could fix the problems before the effort consumers. Okay, it has a more efficient of a field services. Okay, this technologies also can be provide the such services technologies with information or about which parts they have needed to repair or this which ensures the technologies have been necessarily passed with the making of a service call. And the next benefit was an asset tracking. Okay, the suppliers, manufacturers, and the customers can be used the assisting of a management system. It tracks the location and the status and the condition of a product throughout the supply chain. So this make more of a sense compared to the other benefits of IoT because the location tracking the status was the most important and the main on also condition of whatever the product or whatever the okay the production they're going to use for. So by tracking these three major advantage of the things, it can send and it can alerts the stockholders if the whether the goods are damaged or the risk of it being damaged. So by giving them the chance to take immediate or privilege action, the remedy of a situation. Okay, yeah. Okay, this is the assist tracking. And next, the benefit was an increased often a customer satisfaction. When the product is connected to the IoT, actually, the man the manufacturing can be captured and analyze the data, like how the customers use their products or analyzing of on a manufacturers. And the product designers to be build more customer-centric product roadmaps. Okay, it increase the customer satisfaction. How? Like, let's see how. How because how like why the products are connected that manufacturing can capture and analyze the data. How the customers can use the products by analyzing the manufacturers and the product designers to build more customer centric product roadmaps. And the thing was improvement of a facility management. Okay, by manufacturing of equipment, it's going to be sustainable to wear and find tier where are going to be certain conditions in a factory which can sensors can monitor the vibrations. It's like a temperature and other factors it can lead people to have offshore operating conditions. So this was the benefits. The major and the benefits were operative maintenance, more efficient field services, assisted tracking, increased customer satisfaction, improved facility management. Let's see how the risk and challenge is going to be raised for industrial IoT. The biggest the biggest risk associated with the IoT was being to pretend the security. Okay, is the biggest risk because giving a security to it gonna be the device is gonna be a continue of using a default passwords even if they're being put into production. Similarly, it transmits the data as it clears text. Just like as a transparent, it transmits the data whatever it has been. And then with the condition, it could be make it relatively easier for extracting and interpreting the data from coming the IoT devices. Similarly, an attacker could take over an insecure IoT device and use it as a platform for launching an attack against the other net resources. See, not in the industrial IoT devices not only for IoT, but also they can reuse for other things by launching some idea towards it, and they can use for some other network resources also. And coming to the security and device management, it has a major challenges to responsible for an organization of an IoT because in an organization, if they add more industrial IoT devices, it becomes more increasingly important of adopt to an effective device management strategy. More efficiently, the organizers must be able to positively identify the IoT devices to prevent and use of their devices. Okay, establishing 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 of a means of identifying. Wait a minute. Establishing Establishing of the means of an identifying means in each individual devices. It has a critical of a task regarding of a failed devices or performing a device of a refresh. So it can be also not only of a maintaining of a healthy sector, but also it can be tasks such as like a failed devices or performing a devices which gonna be a refresh like it's a starting base. In that way, it's gonna be established identifying some kind of risk. And the same way, the patch management presents the another challenge for IoT, which was it becoming a more common device manufacturers to issue the periodic firmware updates. In this, the organizations would be must have efficient way to check the whether the device is going to be see whether if it is having a latest firmware installed or a deploy of a new firmware has been necessary. Like we have to check whether the thing was having a installed or it really require any necessary of a new thing. So that was a basic challenge. In addition of this, there's a tool gonna be organizations to establish the maintenance schedule. It has a usual maintenance schedule. Even it was also a task. Okay. Industrial applications, just like the examples of industrial applications were factory manufacturing, smart grid, smart power devices, and smart communications, smart cities, smart car, robotics. These were applications of that. There were some applications of that. And what is the future of an industrial IoT? The future of an industrial IoT would be tightly coupled with a trend known as an industry 4.0, which is a fourth industrial revaluation. Okay. Uh, Coming to the basic thing, which was the industry 1.0 was the first industrial evaluation, which was occurred in the earlier stage of late 70s as the companies began. Has begun to use a water powered and steam powered machines in the manufacturing. So in this, Industry 2.0 has been started beginning of a 20th century as resulted the introduction of an electricity and assembled the lines. And earlierly, and with the same flow, the industry 3.0 has been also occurred earlier part of the 20th century itself only, and it was tied to user computers in the manufacturing process. In the first stage, it has been established 1.4 was in the early age of 70s, as they have used for a water powered and steam powered machines. In industry 2.4, they have started for using electricity and assembly lines. In the 3.0, they just later part they have continued this thing only, and then coming to end of the 20th century, sorry, end of the 3.0, they have concentrated on the computers in the manufacturing processes, and now it's going to be inbuilt to the future with industry of a 4.4. Today's our industry 4.4 based on integration of a newer technologies. It was most concentrating upon newer technologies in the operations of our production facilities. So these new technologies could include the cloud computing of artificial intelligence, machine learning, the usage of connecting of electronic devices, popularly we're gonna say. Going forward, the IoT devices would play a major role regarding the digital transformation. So especially as organizations attempt to digitalize their product lines and the supply chains. Additionally, the big data analysis would be involved in the incorporating of an IoT data and make the thing which would be possible for organizations to detect the changing the conditions of a real time and to respond accordingly. Okay. All through the IoT devices would be around for several years itself. Even it's come to real time adoption is still also in the growth only. So according to the report analysis in the market 2022, the global IoT market would be in the billion cities only. and then the growth has been implemented for more of triple percentage. Likewise, in development of IoT stands would be becoming more powerful as well. So the adoption rates could be a change as a 5G becomes a more increasingly relevant, and the more organizations would be begin realize that the IoT could be performed for them, could do more for them, and then the numerically the online resources would be available for organizations that would be get up to speed up on IoT and IoT resources. And yeah, in that way, we have a great future. In the future, we're gonna get Industry 4.4, which it concentrates on a new technology, which it concentrates on new technologies and operations and the production facilities. It's gonna be concentrate on. This way, it has a huge future. Okay, there was some vendors of an industry IoT, which was an ABB Ability, Avava, Cisco IoT, GE Predicts Platform, Platinini, some other Insights Hub. In that way, it has so many vendors of industrial IoT. There are some risks and challenges is that. Okay, let's see why industry IoT was being secure, because earlier stages on the manufacturers and created the IoT devices with a little regarding of a security, resulting in a prescription that the IoT devices would be inherently insecure. So insecure by giving of some similarities between IoT and industrial IoT devices, it's worth of a considering of an IoT would be safe to use towards them by considering that it's safe to use for industrial IoT devices. So as with that, the other connected devices, it must be evaluated on the device by device basis only. And entirely it was possible with the for one manufacturing devices is secure while another isn't. Okay. Even though security is a bigger priority among the devices, the manufacturer then would be even before, for example, the security methods has been used in industrial IoT might be a multi-factor authentication, like end-to-end encryption, the creation of a customized authentication levels. Okay, uh, it's going to be evaluated by device basis only. It entirely possible with the one manufacturer's devices, which secure it has to be secured with the wide of other recently. So even so, such as a bigger priority among the device manufacturers, then it can be it's going to be act as a multi processor also, multi factor authentication. In the 2004, the several technologies companies are included that AT and T was Cisco, General Electronic, IBM, Intel, etc. has been formed as an industrial internet continuum, was being rebranded as an IoT in 2020, where also these groups are primarily objective is to accelerate the adoption of an IoT and related to the technologies. This made the security as a priority, even though they are going far from the form of a security working group. The this working groups would include the technology of a marketing industry digital transformation. This mainly includes marketing industry digital transformations. So yeah, earlier stage they had some other technology, and then later they come to know that the all the companies had come together and they have formed this industrial IoT circuit in the year 2020. So in this way, it has been inbuilt. The benefits of IoT was a predictive maintenance, more efficient field services, assistant tracking. It has an increased customer satisfaction. It has an improved the facility management itself. The mainly the industry IoT was using nowadays, but automatic industry, agricultural industry, oil and gas industry, and utilities. The automotive industry would be used for a robotics to help the predictive and maintenance of a systems to spot the problems which was having in production. So they spot the problems, and the agricultural industry would be used for like a sensors to collect the data and to collect the data about the soil nutrition and often a moisturizer and other variables. Just because for farming they require growth of every minute, every hour. They require a growth of the data. So with that data, it gonna alert the member, alert the production to whether it was getting a spoil of a damaged or anything else. It's gonna intimate a alarm alert for the member. So from that, for that way, they're gonna use for industry, in the agriculture industry. Coming to the oil and gas, they use this is because to maintain the fleet of autonomous aircraft that to use the visual and the thermical use and the thermical imaging of it detect the weather potential problems in a pipelines. This information is gathered, this information is combined with the data and other type of sensors to ensure the safe operations. For utilities, it is used for electric and water, gas metering, as well as to remote monitoring the industry utilities and equipment such as the transformers. So these were the using things. Basically, the IoT industry IoT was has been used for a smart sensors, actuators, and other devices, just like the radio frequency identification tags. So to enhance this manufacturing and industrial processes, these will be networked together to provide a data collection. It exchanged and it analyzes the data. Instead, they gain this process into more efficiently and reliably. As known as industrial internet, is being used for many industries that are manufacturing and energy management devices, oil and gases, etc. So these power, this going to use this power of for smart machines more often for a real-time analysis to take advantage of our data that dumb the machines to have been produced that industrial settings for years. So the driving of a philosophy behind the IoT with these smart machines are they only better than the humans of capturing and analyzing the data in real time. So yeah, and the smart machines are not only for better for the humans one of capturing and analyzing the data, but they're also better for the communicating important information. Or IoT is all about the communicating of important information. It analyzes the data, it collects the data, and it stores the data. It makes sense of an every day that they can check the whether data is following up just like our schedule or not. With that, they if it get any changes, then it's going to be implemented with the resources of actions. So it was a major part compared to any other networks. The data that it has for a 24 hours is going to be recorded. So it was not it's a simple thing. It was a major advantage to any sector, even it's come to the agriculture, oil or gas or an industrial sectors, wherever. It was a smart way and it's a smart activities. So by the it's a communicating important information is like action to have just nonsense. It is used to drive the business decisions as faster and more efficiently. Just like a connected sensors and actuators enable the companies to pick the inefficiencies and the problems sooner. It saves the time, money, which was a more of an advantage. It saves the time and money for every sector where we use IoT. And we're supporting often a business artificial efforts in the manufacturing facility, and it provides a potential to provide a quality control, sustainable green practices, supply chain traceability, and over the supply chain efficiency. In this industrial setting, IoT is a key process such as the predictive of maintenance, enhance the field services, energy management, assist tracking. So the working would be just like the working of an industrial would be done just like intelligence devices connected to form systems or that monitor collect. It is all with three steps, which was a monitoring the data, collecting the data, exchanging the data, analyzing the data. It monitors the three steps, which was a collect, exchange, analyze the data. It is all of the industrial IoT work. Just the three steps. It monitors the three steps, which was a collect, exchange, and analyze the data in the different formats we have discussed. It makes sense and communicate, and it stores the information in itself themselves and whether it's going to be public or a private, wherever it, the intersection of the communication would be done and going to be stored just like a information of one raw data at the people. not only for small platforms, in every in other platforms also, it's gonna have a huge impact. Coming to the IoT platform or in-process server, whatever the gate or IoT gateway or edge gateway, it sends, accurates, and it edge nodes. All through the internet, things have a more technical, more technologies in a common, or even platforms of sensors, connectivity, mission-to-mission communications, and data analysis. The IoT systems could connect the devices across the multiple verticals, including agriculture, healthcare, enterprise, uh, enterprise, consumer, utilizing government and necessities. IoT would be include smart devices like a fitness bands, other applications like a generally don't create emergency situations if something goes in this. So the IoT applications would be, on the other hand, would be connect the missions or connect other missions or on emissions in sectors that be such like oil or a gas and utilities manufacturing. System failures are a downtime to the industry. IoT deployments can result in a high risk of or life-threatening situations. The IoT applications would be morely concentrated with the improving of efficiency of health or as a safety, which was having a user-centric nature of an IoT applications. So these applications would be, on the other hand, will connect the machines and vehicles on a devices to sensors such as an oil or a gas, utilities and manufacturing. System failures and a downtime deployments can be result in a high risk of or life-threatening situations for industrial IoT. This can be more concentrated on improving of efficiency, health, or in that way. Just like I have mentioned, some numerous industries uses automatic industry, agriculture industry, oil and gas industry, utilities, and etc. The benefits would be productive maintenance, more efficient field services, asset tracking, increased customer satisfaction, improved facility management. These would be benefits of that. And it is secure just because it creates regarding of security, the perception of an IoT would be inherently insecure. So this gives some it has some more similarities of internet of an IoT things industrially. As we know it, this way it's gonna be enhanced. In initial stages, they in 2014 they have been enhanced with some other. It formed agriculture internet, and then in 2020 it has been implemented for further stages. Yeah, this is what I have said. Today's session is all about agriculture and industrial management. So yeah, that's it for today. Tomorrow let's discuss of on a health, retail, finance, manufacturing, etc. things. Wait a minute.